I'm not really sure from which past paper does this question come, and I know that it's not the first time you see it. We've actually done it, I think, in one of the lessons, but I don't think we did it well enough. And I also don't think I appreciated the beauty of this question. So I think we should do it again. All right. So let's go. Now, this is how the statement reads. They say, in this diagram, PK, the pink one, is a tangent to the circle at the point K. The chord LS is extended to the point P. N as well as M are points on the line PK and SP respectively, such that MN is parallel to SK. The chord KS and LN, they intersect at the point T. So what's the most important thing you need to know from this statement? Well, it's the fact that PK is a tangent. That's the first thing. And the second thing is MN is parallel to SK. Those are the most important ones. Now, before we can say anything here, let's identify all the theorems that we see. And also identify everything which is not a theorem, but which can assist us. And I think by now you understand what I mean. I mean maybe an exterior angle of a triangle, angles opposite equal sides, things like that. Parallel lines, alternate angles corresponding, and things like that. They're not really theorems. Well, they are, but we don't treat them as theorems. They actually are theorems because they can be proven, but nonetheless, we just accept them without proving them. We accept that whenever two lines are parallel to each other, and we have a transversal line. I hope you still remember what's the meaning of the word transversal. That's what you used to say back in grade 9. So if you have two lines which are parallel to each other, this is a transversal line. It can be like this, it can be like that. We don't care. Okay. Well, it's always nice to remember some terminology that we use in mathematics. So just to make you, or rather to show you what is a transversal in this case, the line NL is actually the transversal. The line MK is also a transversal because those two lines, yeah, they do the thing, so they're transversals. Okay, let's begin. So the first thing we can see here is the pink line is a tangent to this circle at the point K. And you know that we quickly run to the tan chord theorem. And we say the angle between a tangent to the circle and a chord is equal to the angle in the alternate segment. That's the first one. But that's not all. The angle between a tangent to the circle and a chord is equal to the angle in the alternate segment. All right. Well, that's all with the tan chord theorem, or at least that's all that the tangent line is telling us in this case. What else? Well, do we really have another theorem here? Well, I'm not entirely sure. I can't think of any. No, we don't have angles in the same segment. No, we don't. No, I think that's just about it. Angles on a straight line, that's not a theorem, and things like that. So I think that's that, except for the parallel lines, of course. And yes, the parallel lines are giving us alternate angles. So I've marked the alternate angles with the blue Z, or N if you like, whereby angle M2 is equal to angle K2. And we also have corresponding angles because we have an F shape. Well, this is the F shape, which means that this angle here is equal to that one because they definitely correspond with each other. So yes, that's what we can say. Are they the only corresponding angles? And that's a big no. We do have other corresponding angles here. What are those? Well, this is an F shape once again. So this means angle N1 is equal to the whole of this, K1 plus K2, which I prefer to call PKS. So yes, well, I think we've done enough. You don't need to talk about co-interior angles because we know that they add up to 180. And since we are not given the magnitude of any one of them, then it means it's not really helpful having that knowledge. Nevertheless, let's get down to the first question. And this is actually for 4 marks. So what is it saying to us? Well, let's see. They say, please prove that angle K4 is equal to angle NML. In other words, we need to prove that this pink angle is equal to angle what? NML. Where is NML? This angle. Ah, okay, fine. We can do that. But I just need someone to tell us, to give us a concept. This is 4 marks. So I need someone to give us a concept. Like if they say prove that two angles are equal to each other, what is the main thing that we need to do? What is the concept? How do we prove that two angles are equal to each other? Well, I'll give it to a volunteer. Anyone who has an answer can go ahead and turn on the microphone and speak. But of course, if no one volunteers, then it means I'll have to ask you. So, yes.
Yeah, please repeat the question.
Sorry, sir, I couldn't catch that.
I'm saying, can you please repeat the question?
The question is, what is the concept? How do we prove that two angles are equal to each other? What is the main thing that we need to do? Okay, no, no one wants to answer it. That's fine. So what we said is we need to find an angle which both of them are equal to, and they will be equal as a result. That's the concept. Because what we're using here is the fact that if x equals y and y equals z, then it stands to reason that x equals z because they're both equal to y. That's the concept. In other words, we need to find a common angle which K4 is equal to and angle NML is equal to. And once we find that angle, then it means these two angles must be equal to each other because they're both equal to that one. Okay, let's begin. There's actually many ways in which you could have done this one, or rather could do it because you haven't done it yet. Right. Now, the first way is already obvious. What is that? In our analysis of the statement, we said angle K4 is equal to angle S1. That is what we said. And the reason for K4 to be equal to S1, that's because of the term called theorem. Well, this is what we said. Okay. But then we realize something. Once again, in our analysis of the statement, we said angle S1 is actually equal to angle NML. Because if you remember well, we identified an F shape. And we said, well, they are corresponding angles. Don't forget to give us a reason why they correspond. The reason why they correspond is because NM is parallel to KS. Well, SK, I'll just say SK even though it's not in the correct alphabetical order. Nevertheless, it's much better to say SK than KS, is it not? But no, it's not so important. So now we have managed to find a common angle, which both of these are equal to. Then the conclusion is they must be equal as a result. So yes, there is your 4 mark. Well, it's 2 mark for each of these actually. For this statement and a reason, for this statement and a reason, then you just get your nice marks like that. I don't really think for the conclusion you get a mark, but you may. So maybe they'll give one of those a single mark and then give you a mark for that conclusion. But that is that. That's the first way in which you could have said it. Then the question is there another way in which you could have done it? If you didn't want to use this approach, well, there should be another way, but I think I'll just leave it here. I think it's fine if we did it like this. Okay, so now we are going to go through life understanding that angle K4 is equal to NML. Just so I remember, I'm just going to say K4 here equal to that, equal to that. And I'm just going to clean my diagram so that, we appreciate clean things, don't you? Okay, I think that's enough cleaning for the day. Spring is yet to come anyway. So yes, I'm just going to clear this part. Now we have 4 marks, which is in the bag. And this question is out of 23 marks. No, we still have to get more marks. And this is the advice I have to give you. You see those 6-mark questions, those challenging ones, GF squared equals something. It doesn't mean if you don't know how to get there, you can't get any mark from that 6-mark question. So surely, something from similarity, from the fact that the corresponding sides are in the same proportion. Yeah, just writing 2 ratios there, maybe a mark can come out of there. So please try to do something. Try to fight. Don't just give up and say, hey, no, this is a 6-mark question. It's not for me. No, you can still get some marks there. Okay, what is the next question saying? Well, it's actually a 1-mark question. It says, prove that the quadrilateral KLMN is a cyclic quadrilateral. Where is that? Well, it's K, L, M, as well as N. So this nice quadrilateral that you see here, The question is saying, please prove that it is a cyclic quadrilateral. Now, I need a volunteer. Can anyone tell us what do we do when we prove that a quadrilateral is cyclic? What is the concept? Well, there's two main things that you can do, actually three, but you can just tell me any of those three, and I should be happy. Yes, sir.
So we can prove that the exterior is equal to the interior opposite.
We can prove that an exterior angle of this quadrilateral is equal to the interior opposite angle. Thank you so much, sir. Then can anyone else tell us something differently? What else can we do? Because you need to know all things, everything that you can do in order to prove that something is a cyclic quant. Just in case in the exam they don't give you the one that you like, you know? So yes. Anyone else?
Um,
Yes, I'll
I
say.
think we can prove if two equal angles subtend the same arc or chord.
Please come again.
We can also prove if two equal angles subtend the same arc or chord.
Okay, I see. So you're saying we can prove that two angles are subtended by the same arc or by the same chord. In other words, we can prove that they're in the same segment. Okay, thank you so much, Elsie. There's one more. Anyone who can tell us the last one? Yes, sir.
So you can also prove that opposite angles add up to 180.
We can prove that the opposite angles of this quadrilateral are supplementary, which means they add up to 180. Thank you, sir. Now the question is, can we use that one, the last one in this case? And the answer is no, because we are not given any magnitudes of the angle. We don't know any size of any angle here. We don't have a 90-degree angle. We don't have anything. So it's really impossible to prove that. Um, yeah, to prove that they add up to 180, the opposite angles. So it's also difficult proving that two angles are in the same segment. Let's be practical. If you wanted to prove that, it means you need to prove that angle M2 as well as the whole K2 plus K3. If we can show that M2 is equal to K2 plus K3, then you have proven that these two angles are in the same segment and therefore this would be a cyclic quant. That's not the only angle at which you can look at it. You could have also considered this one and saying, if I can prove that angle M2 is equal to angle L1, then those two angles are subtended by the same chord and therefore they're in the same segment and this is a cyclic quant. But it's really difficult proving those. The easiest one to prove is exterior angle of a quadrilateral is equal to the interior opposite angle. If that is true, then this is a cyclic quant. And remember, when you choose your exterior angle, you need to make sure that you go to one of the extensions or rather extended sides of your quadrilateral. For instance, N1 is indeed an exterior angle. K4 is an exterior angle. M1 is also an exterior angle. Now the question is, which one is the easiest to prove? And since it's only 1 mark, you should have a hint that maybe it depends on what I did above. And as a matter of fact, it does. But how does it do? Remember, we have shown that angle NMN is equal to angle K4. And definitely K4 is an exterior angle of this quadrilateral. So that's what you can say. You can say angle K4 is equal to angle NML. Well, this was already proven above, but it's still necessary for you to tell us this. Then you can make a conclusion and say, therefore, KLMN is a cyclic quant. You need to give a reason why you say it's a cyclic quant. Well, that's because you use the converse of an exterior angle of a cyclic quant. That's the first way in which you can give a reason and say converse of that. Or you can say exterior angle of a quadrilateral is equal to the interior opposite angle. Because that's what the converse is saying. It says, if an exterior angle of a quadrilateral, an ordinary quadrilateral, if that exterior angle is equal to the interior opposite angle, then that quadrilateral is a cyclic quant. This is an implication sign. It means implies or then. I see that they also use it in your memos, but they only use the one that has only a single line. So when I use an arrow like this, or you use this, they mean exactly the same thing. It's an implication, just in case you were wondering when you see this in your memos. But I'm not going to ask if you have a question on this one, but we'll just go on to the next question. This is the most important thing. You are now going through life believing that this quadrilateral is cyclic because you have proven that it's a cyclic quant. Which means you can now use the fact that it is a cyclic quant in order to answer questions that follow. That's what I mean when I say going through life believing that it is cyclic. What is the next question saying anyway? And this is a nice 5-mark question. They say, please prove that triangle LKN is similar to triangle KSM. That's what they say. Okay, fine, we can do that. It's not a problem. But firstly, we need to identify the triangles. Where are they anyway? Well, I'll have to overwrite my beautiful quadrilateral here, but nonetheless, if we look at KSM, it's actually the blue triangle. So I'll just say something like this. Now, what about LKN? Well, this is L, and this is K, and this is N. This is the quadrilateral in fact, the triangle I'm concerned with. So the green one as well as the blue one, we need to prove that they are similar to each other. Well, that's fine. So we do what we do best. We tell them that we are focusing in triangle LKN as well as in triangle KSM. And in these two triangles, something interesting is happening. And this is a heads up. This is a heads up. Is it right to say that? Well, I'm not sure. No, it's a heads up. I'm giving you heads up. Hey, I know, I'm not sure. Okay, I just want you to be aware that even though it's a 5-mark question, it doesn't necessarily mean the angles will be obvious, that these angles are equal to each other. You may have to work for them. For instance, you may have to, like, in order to show that two angles are equal, it may be necessary to find another angle which both of these are equal to, and then say they are equal as a result. So yes, let's begin. Well, we really do need to work for the 5-mark in this quiz. And how do we do that? Well, this is what I want you to realize. Because as it stands, we really can't make a connection between those two triangles. Nothing is obvious that those angles are equal to each other. At least in my eyes, no? So this is what I'm going to say. If we go to this chord, because we now know this is a cyclic chord, I might as well draw a circle around those points, but it's not necessary. Just believe that it's a cyclic chord. Well, it's on an invisible circumference. Yeah, let's say that. So since we are working for our angles, we know that since this is a cyclic chord, it means that angle M2 is equal to angle L1. But where am I going with this? Well, that's because from the parallel lines, we know that angle M2 is equal to angle K2, which means that angle K2 must be equal to angle L1 I mean, sorry, because they're both equal to M2. I'm making a connection in two triangles. Well, I know maths is not really understood verbally, so let's show you what I'm saying. I'm saying angle L1 is equal to angle M2 because they are angles in the same segment. Okay, but we know that angle M2 is equal to angle K2 because they alternate. And the reason why they alternate is because NM is parallel to SK. So what? So this means angle L1 is equal to angle K2 because L1 is in triangle LKN and K2 in triangle KSM. We managed to make the first connection. All right. Now it's time to make another connection. And how do we do that? Well, easy. This is now a cyclic chord. We are now going through life believing that it is a cyclic chord. So let's take advantage of this. What am I saying? I'm saying if you go to this chord is going to subtend angle M2 at the circumference of this cyclic chord. The very same chord. No, I'm lying to you. I'm lying because it's only going to cover this small angle and it's going to leave K1 out. So no, that is a wrong connection to make. Okay. Okay, fine. So what else can we say then? We know that S2 is equal to what? What did we say S2 is equal to anyway? Have we ever made that connection to S2? I think we have previously. Okay, no, let's forget about it and find something else. I really believe that we can make a connection looking at S2 as well as the whole of angle K except K4. And what would that connection be? That's a good question. Okay, I thought I got it, but seems like I haven't got it. I just need to look hard enough. It's right here in front of my eyes. That's the beauty of Euclid's. Things are already here. And just to give you a word of advice, I do have different colors in my room, so like different pens. I bought them at Pep. They're not expensive. I think it's 30 something rands. So I think they can help you, man, when you are analyzing your diagram in the exam. So just try to buy different colors. It's really a good investment. They do come in handy. Okay, but it doesn't change the fact that this problem is boxing me. Well, it's not. I just need to open my eyes and that's it. So what do these parallel lines tell us? Because we see that the cyclic quad is done doing its job. We can't talk about angles in the same segment anymore. And the tan chord theorem is also not going to assist us. No, it's not. So let's look at these parallel lines once more. So looking at these lines, okay, Njapa is coming to the rescue. He says N3 equals M3. M3 equals N3. Okay, let's see. Let's see. So this is N3 and this is M3. Okay. So what would be the reason for those two to be equal to each other? Okay, they're angles in the same segment. They're subtended by the chord KL. Okay, thank you, sir. Thank you, sir. Yes, they're subtended by the chord KL. Okay, that's a good one. Thank you, sir. So yes, angle N3 is equal to angle M3 because they are angles in the same segment. Okay, so now we have everything that we need. We have done everything. So now it's time to make a conclusion. So well, given everything here, then it means angle S2 is also going to be equal to angle NKL because of the sum of interior angles of a triangle. Yeah. And then we can conclude and say, well, this means the two triangles are similar to each other. Well, thank you, sir. Thank you, sir. I appreciate the hours. All right. So, yes, I have to apologize formally. Yes, so it's actually Nosipo who was assisting us in this problem. I'm not sure how I read the name Njapa here, but sorry, Elsie, and thank you once again. Thank you, thank you, thank you. Okay, so now the two triangles are similar. Then this is what they tell us. They say, if it is given that the length of LK is 12 units, and it is given that 3 times Kn is 4 times Sm, then they say, please find the length of Ks. That's what the question is saying. All right. So we need to think about similarity first because we have just proven two triangles to be similar to each other. So it means we just need to identify the sides that are in the same proportion, the corresponding sides, that is to say. So let's see, which one is going to be that? We go to the angles which are equal to each other, and we know that angle L1 is actually equal to angle K2. So which means if I go to the smaller triangle, I'm going to take SM. It corresponds with Kn. Then I say this must be equal to what? Well, we shift our focus. We go to another pair of equal angles. So Nosipo told us that N3 is equal to M3. But since I want to begin with the smaller triangle, then it means if I take Ks or Sk and I divide it by KL or LK, no, I'll just say KL in this case. It must be equal to what? Remember, you don't need to write all three ratios, right? But I'm just going to write all three of them. And of course, I'm going to drop the irrelevant one. So yes. We also know that this angle NKL, is equal to angle S2. Yes, that's what we know. So this is how it should be. And of course, going to the smaller triangle, I'm going to take MK and I divide it by NL. You don't need to write all three of them once again. But of course, this is because the two triangles are similar. What are those? LKN is similar to KSM. Right. Well, of course, you'll give them something like this. So let's choose the relevant one and drop the irrelevant one. According to what we are given here, we see that Kn is there, Sm is there, Lk is there, Ks is there. So this means that this one is actually irrelevant. We don't need to write it. No, we don't. So we can just remove this one, but I'm going to keep it here for future reference. I don't want to start all over again when I have to do something else. Right. So that's the first thing we are going to tell them. Then what is it we say after that? Well, easy. We are going to come to this ratio here. Which ratio is that? This one. And we need to rewrite it nicely. Well, nicely how? Let's write it as a ratio. It's up to you whether you divide by Kn or you divide by Sm. But then since Sm is in the numerator here, then it makes sense for us to divide by Kn. So yes, we want to bring the letters to one side and the numbers to the other side, which means I need to divide both sides here by what? I want to get rid of the letters. I also want to get rid of the number. That's what I'm going to say. So I know that if I take Sm and I divide it by Nk, or Kn, well, the answer is going to be 3/4. It's not something I had to think about. It's something I was given. So since this one is actually 3/4 like that, then it means that the other one, what is the other one anyway? Well, it means that Sk over Kl is simply going to be 3/4 as well. And here we are looking for Sk. So, but we know the length of Kl. It's given to us as 12. And if we now multiply these two, then that's fine. We can easily find the length of Kl. And how do you do it into your calculator? That's easy. You don't need to show the steps here. You just say this one times that, this one times that. You go to your calculator and say, in the numerator, I'm going to have 12 times 3. And then I have to divide this by 4. Then I find that the length of Sk will simply be 9 units. So yes, that's how it works. They gave us one of the ratios there, so we had to use that to our advantage. And then we should have been fine. Okay. So now we know that Sk is 9 units. So let's go and put it. It can help us. You never know. 9 units there. And what about Lk, Kl? That is 12 units. Well, those are the only lengths we were given, right? So let's go to the next question. What does it say? Well, this is what it says. It says, hey, I can't find it. Just need to quickly go into your group chat. And I have it. Right. Now, this is what they say. They say, if it is further given that the length of NL or Ln is 16 units, Ls is 13 units, and Kn is 8 units. Then they say, determine with reasons the length of Lt. So let's try to fill this up on a diagram. Where is Ls? Well, Ls is just this length there, so it's 13. And NL is the entire length, which is 16. And of course, Kn is 8 units. And we are looking for LT, which is the length here. That's fine. The question is, are we going to use similarity once again? And the answer is not necessarily. Why? Well, that's because in our similarity, we don't have LS. That's the first thing. We also don't have LT in our similarity here. That's what I mean when I say similarity. So we can't really use that. No. However, if you look at this carefully, you actually realize that these sides are there in the proportionality theorem, except Kn, of course. And yes, we do have the proportionality theorem because we have a triangle, which is this one. And this triangle contains the parallel lines NM and ST. So yes, we can use that. However, the LT that they're asking from us is the second longest side on your triangle. LN, they gave it to us. It's the whole length. All right? Now, furthermore, we are looking for, okay, that's the LT. We already said it. They also gave us LS, which is the second longest side. And if we have LS, we can actually get ML if we know what is the length of MS. So MS is just a smaller part of the puzzle that we need to find. If we know MS, then we can just use the proportionality theorem and be glad. But the question is, how can we get MS or SM? That's easy. We know the length of Kn. We know that Kn is there in this ratio. Sm is there as well. More precisely, we know that Sm over Kn is 3/4. So that's just easy. It means we are going to come to this ratio and we just do the substitution. We say Sm over Kn. Well, Kn is 8 units. And this ratio is 3/4. Then we can find the length of Sm. We cross multiply Sm times 4, 3 times 8. So that in the numerator on your calculator, you have 3 times 8. And this is divided by 4. So you get 6 units there. Okay. Now we have the length of Sm. How does it help us? It helps us in finding the entire length of Lm. So now we know that we take this 6, we add it to the 13, and we get a length of 19. Now we can state the proportionality theorem and say, if we take LT, we divide it by the whole length. This will be the same as when we take LS and divide it by the whole length. And of course, using the reason that I like, we say a line is parallel to one side of a triangle. Right. Then of course we just divide there, that's fine. Now we are looking for LT, yes, but LN was given to us as 16. The length of LS was given as 13. the entire length of LM is simply going to be 13 or 19, I mean, sorry. Then we can just do the thing, the cross multiplication, that is to say, and get the length of LT. So you say LT times 19 equals 13 times 16. And when you go to your nice calculator and you say 13 times 16 divided by 19, well, unfortunately, you're going to get a decimal. And please answer it according to the instructions. If the instructions said take it to 2 decimals, you should do so. But if they said to 1 decimal, then it was just going to be 11 units. In fact, I'm lying. To 1 decimal, it's 10.9, sorry. Or to a whole number, it is 11. But yes, please read the instruction and understand why. I think this problem is really powerful if you can, I don't know. But yeah, no, it's a very powerful problem. It's really powerful, and I think it's helpful. Okay, so this is how the statement reads in this case. They say in this diagram, OP is parallel to LM such that the area of triangle KOP is equal to the area of the quadrilateral OPLM. Well, this is really important, so let's not forget this, all right? Yes, OP is parallel to LM such that the area of triangle KOP, what is KOP anyway? It's this smaller triangle which is blue. Yes, the area of this triangle is equal to the area of the quadrilateral. And of course, there is only one quadrilateral here, and this is it. Well, that's fine. Now, furthermore, they say KYX. In other words, this vertical black line is perpendicular to OP as well as to LM. All right? At the points Y and X, respectively. So this means I should be indicating this is 90 degrees, and of course, this is 90 as well. Well, this is what we are given here. So the only thing that is important from the statement is the area of this blue triangle is equal to the area of the quadrilateral. Another thing, KYX is perpendicular to OP and LM, and also OP is parallel to LM. Well, everything is important in this case. That's fine. Now, this is what the first question is saying for only 3 marks. It says, please prove that triangle KOP is similar to triangle KLM. Well, this is what they say. Now, what is KOP? It's the smaller one. What is KLM? The bigger one. That's fine. So, we do what we do best. We tell them that we focus in triangle KOP as well as in triangle KLM. Now the question is, what is happening in these 2 triangles? Well, first things first, we can see that they share an angle, which is angle K. But I will respect it and call it angle LKM. So LKM is equal to LKM. It's the same angle. So common angle. But since we have parallel lines, we understand that these two angles are equal because they correspond, but they're not the only ones. These two are equal as well because they do correspond. So that's nice, very nice. So we can say angle O1 is actually equal to angle L because they are corresponding angles. And the reason why they correspond, that is because OP is parallel to LM. Moving on, angle P1 is equal to angle M for the same reason. And now we can conclude and say, well, these two triangles, they must be similar to each other. And of course, we purely used the angles in order to deduce this. Well, any question on this one? No question. Okay. So now we are going through life understanding that these two triangles are similar to each other. So what does the next question say? Well, this is what the next question is saying. It says, please prove that ky is to kx will be equal to OP is to LM. Prove this. Well, that's fine. So now we go to similarity first. And we understand that the angle opposite, or rather the side opposite angle K, that is OP in the smaller triangle, and that's LM in the bigger triangle. So I say, if I take OP in the smaller triangle, I divide it by LM in the bigger triangle, this will be the same as what? I go to similarity first. Well, this is going to be the same as when I go to angle O1 and I say, well, those are the sides opposite those equal angles. In the smaller triangle, I'm simply going to have ky, but in the bigger triangle, I'm simply going to have kx. Yes, this is what I'm going to have. I think I copied the question in an incorrect way, no? The question said prove that ky is to kx equals OP is to LM, and it's just a 2-mark question. Okay, did I state my things right here? OP, it's the one opposite this in a smaller triangle. And LM, yes, it's the one opposite that in the bigger triangle. Going to O1 again, ky in the smaller one, kx in the bigger one. Okay. No, I didn't do anything wrong, so that's just it. I didn't think it was this straightforward. I wasn't expecting it. So we can add and say it's because of similarity, but I'm just going to write the third side right away, just in case we can need it. And yeah, no, this is a lie, guys. I'm lying to you, you know? But am I lying to you? Of course I'm lying to you. It's not supposed to be like this. Why? No, it's not supposed to be like that. This angle L is opposite this side in the bigger triangle. Yes, because now I'm now doing it as if the bigger one is this one, which is wrong. I was wrong to say that. But yes, looking at the OPs, that is right. Yes, OP in the smaller one, LM in the bigger one. Then going to O1. Well, O1 is opposite K1. This one is true. But angle L is opposite KM. This is what it should be. And I'm going to add the third ratio, even though I'm going to drop one of them, of course. But I still don't know which one I have to drop. So I'm safe to write all of them. So I say, okay, fine. If I now shift my attention and I go to, maybe let's say this one. So in the smaller triangle, I got it wrong for the second time, but nevertheless. Yes, if I now go to the smaller triangle, angle P1 is opposite KO, and angle M is opposite angle KL. So this means I'm supposed to have KO, which is divided by KL. And I hope you realize I'm making mistakes. Please make sure that you don't do the same mistakes as well. Well, the reason why I'm making mistakes is because I'm an old man. And of course, old men make mistakes. But when you are still young, so you need to make sure that your eyes are on top of the game. It should be KP, not KY. Because when we now say K1, KY, I mean, it's like we are reducing it to this triangle. And that's not it, because we proved the blue triangle to be similar to the pink. So we must be consistent. Please don't be confused as I was. Right. Even though we don't need all three of them, I'm just going to write all three of them. But when, of course, you don't write all three in the exam, although you won't be penalized if you write all three of them, but it doesn't make sense for you to do that. Well, the reason why these sides are in the same proportion, of course, that's because triangle KOP is similar to triangle KLM, right? But then you still haven't answered the question. So if you look at this similarity here, not similarity, I mean the ratio that we need to prove, we don't have KY over KX so far, but we do have this OP over LM. So this one is a little bit heavy, all right? We are still deciding which one to drop. But then this KY over KX, I want you to realize that it's actually there in one of these half triangles. So if you halve this and then you only focus on that, then you can see that if you only focus on this triangle, yes, you're going to get KY over KX. If you use the proportionality theorem, that's what we can say. But then how are you going to use this proportionality theorem? The standard has already been set. KY is a shorter length, well, the second longest length, of course, and KX is the entire length. So now you know how to go about it. If you now go on and you say KO over the entire thing, which is KL, must be equal to KY over the entire thing, which is KX. And then you can state that you got this wisdom from the proportionality theorem. So that's how it works. And of course, according to this, you now understand which one do you need to drop in this similarity. And it's just going to be the one that is in the center. So you'll just tell it to go home. We'll see it some other time. It means you only had to use those two other ones. But now you realize something. What is that? OP over LM is equal to KO over KL. And also, KY over KX is equal to KO over KL. Then this means they must be equal to each other because they're both equal to KO over KL. Yes, that is that. So please don't make mistakes. Don't go to the wrong identification of your triangles because it's really going to mess up your answer. You will get incorrect values. Any question here? No. Well, it was just a 2-mark question. So for making this statement, for making that statement, yes, you get your 2 marks. Well, this one, they assume that you understand that if those ones are equal to each other, then therefore these ones must be equal as a result. So they decide not to give you a mark, which is understandable. Hopefully you're not offended. Okay, so now we are going to go through life understanding that ky over kx is equal to OP over LM. Then there comes the last question, which is a 6-mark question. So what does it say? Well, it says, please prove to us that if you take KO, you divide it by KL, the answer will be 1 over square root 2. This is what they ask you. Imagine. Well, from this proportionality, we know that KO over KL equals KY over KX. But imagine, how can we prove that it's equal to 1 over square root 2? Where does the square root suddenly come from? Well, for this one, you need to remember what you were told in the statement, because otherwise it would have been a useless piece of information if you can't use it anywhere. What am I saying? They told you that the area of triangle KOP is equal to the area of the quadrilateral OPL, okay, OPML, but I'm just going to say OLPM. Like that, that's fine. So this is what we were given. We didn't think about it. It's what they told us. But then let's put it into practice. What does it mean? Well, this is what it means. So if we know that the area of the blue triangle is equal to the area of the quadrilateral, then what does it mean about the area of the entire triangle? If we know that this area is equal to that area, then it stands to reason that the area of this entire thing must be twice as much the area of the blue triangle. That's what it means. So it means the area of triangle KLM must be twice as much the area of triangle KOP. If it is given that those two are equal to each other, that's what it means. But now the question is, how do you find the area of triangle KLM? We do have a perpendicular height in this case, so it's all good. It's half base, the base is LM, and the height is KX. What is the area of this blue triangle? Well, it should be half base by height as well. The base is OP and the height is KY. Well, this is what we are saying. And of course, if you simplify this further, you have 1/2 LMKX, which is equal to OP times KY. That's what it means, right? However, we have a product, the equality of two products here. So we need to convert this to a ratio. And how do we do that? It's like you're saying half X equals Y. That's what you're saying. Now, what's the meaning of this? Well, it actually means if you take Y and you divide it by X, then the answer is going to be 1/2. That's what it means. Because Y, no, nothing. But yes, that's what it means. So let's go ahead. So when we go ahead here, we just divide both sides by LMKX. And we find that OP times KY divided by LM times KX will be equal to 1/2. This is what we get. Okay, so what? We remember the rememberables. And what are those? Well, this is what we know. We know that every time we see OP over LM, we actually see KY over KX. That's what we proved above. Do you remember that? Yes, we proved that KY over KX equals OP over LM. So we tell them this problem, we say, but we know that OP over LM is equal to KY over KX. It was proven above. So what? Well, that's a good question. This means when you see OP over LM, you can choose to write KY over KX. But according to what you're hoping to achieve, you're hoping to prove that KO over KL. So, yeah, you can choose to say, therefore, where I see OP over LM, I'm just going to replace it with KY over KX, which means I have KY over KX all squared, and this is equal to 1/2. Do you see where the square comes from? It comes from the fact that where I see OP over LM, I put KY over KX. That's where it comes from. So ultimately, I had something like this. And KY times KY, it's KY squared. KX times KX, it's KX squared. You could have decided to write it as KY squared over KX squared. But I just prefer to say KY over KX, which is all squared. Then I find the square root on both sides. So then we find that KY over KX must be equal to 1 over square root 2, because the square root of 1 is 1 and the square root of 2 is square root 2. Then we remember something. What is that? We know that ky over kx is equal to ko over kl. Well, this is where it comes from. It was already proven above. Yes, it was proven, so that's what you tell them. So then what's the conclusion? Well, since those two are equal to each other, then it stands to reason that ko over kl must be equal to 1 over square root 2. So that is how it works. So in this case, they say to us, in the diagram that you see here, K, G, and H are points on the circle. That's true. And FG, the green one, is a tangent to the circle with center E, the pink circle, that is to say. And then they say, what? They say a semicircle with center F, the black one, is drawn. The points D and E, they lie on the semicircle. We can see that. And CD as well as CE are tangents to the semicircle at the points D and E, respectively. Then furthermore, they say CD is parallel to HE. Well, they don't really look like they're parallel, but let's just accept they are parallel. Now I can always fix this, can I not? Of course I can. Yeah, no. Let's do things the right way. So I think it's much better now. More or less, you're convinced that they are parallel to each other. Okay. So what is the most important thing you need to know from the statement? Well, CD and CE are tangents. E is the center of the pink circle. F is the center of the semicircle. FG is a tangent to the pink circle at G. Yeah, that's just it. All right. Now, this is the first question. The first question says, please give a reason, and it's only for 1 mark. Give a reason why DC is equal to EC, or rather CE. Says, can anyone tell us the answer? Why is CD equal to CE? What is the reason behind? Well, no one volunteers. No, sir. What do you think, Mavilagasi? What is the reason? But thank you, sir, for wanting to answer. Let's choose freshers. No. Other people, they don't want to say anything in class. What's the reason, I'll say? Okay, we'll take a friend. What do you say, Mama Fadi? Why are those two lines equal to each other?
Tangents from the same point.
Tangents drawn from the same point. So why didn't you say anything, Elsie, when I asked for a volunteer? But nonetheless, that's the reason why those two lines are equal to each other. So now we are going through life, understanding that these two lines are equal to each other, or tangents as we should say. Then there comes the next question. What is the next question? It says, please prove for 6 marks that triangle DCE is similar to triangle HEK. Well, this is what they say. All right. So where are these two triangles anyway? Well, DCE is the triangle that contains this one. So yes, I'm just going to remove the red one. So it's the one that contains two tangents. And what about HEK? Well, HEK is simply going to be this triangle. Which one is that? It's the smaller triangle, but I think I should highlight it in turquoise. This is the name of the color, turquoise. I don't just teach you maths, guys. I teach you colors as well. So I'm a good tutor. Right. Yes, it's this smaller triangle. It is HEK. So how can we prove that those two triangles are similar? Well, of course, we begin where we should begin. So we say, in triangle DCE, as well as in triangle HEK, what is happening? Well, since we can see a Z here, because these two lines are parallel to each other, so we have a Z shape. Then it means angle C must be equal to angle E2. And the reason why they equal to each other, that's because they alternate. And the reason why they alternate, that's because CD is parallel to CE. Okay, we made the first connection. That's fine. Now, how do we make the second one? The second connection is really going to be difficult. Why? Well, that's because if CD is equal to CE, then it stands to reason that angle D is equal to angle E1. And similarly, if you go to the smaller triangle, you can see that these two sides are equal to each other because they are radii of the circle. EH is the radius and so is EK, which means these two angles are equal to each other. What is the problem in our case? The problem is, are you going to say this angle D is equal to that? And if you say that, on what grounds are you saying those two angles are equal? Do you see that? So that's a rather good one. But this is what I can say to you. What is it I can say? I can say, go to each triangle here and express one of the angles in terms of angle C. That's what I can say, because at the end of the day, you need to explicitly show that maybe angle D is equal to K1. We can't just accept that they're equal. All right? So how can we make that connection? Well, let's go to the big triangle. What is it we know from the bigger triangle? Well, this is what we know. According to the sum of interior angles of a triangle, we know that if we take angle C, we add it to angle D, we also add it to angle E1. The answer is going to be 180 degrees. If we go to the smaller triangle, we know that if we take angle K1, we add it to angle H. We also add it to angle E2. The answer is 180 as well. All right. Now, what is nice in both of these cases is angle C is equal to angle E2. Even though these two are also equal to each other, we need to express one of them. Maybe express angle D in terms of C, and maybe come here and express angle H in terms of C, or even angle K1 in terms of C, so that we can explicitly see that these angles are equal to each other. That's what I'm trying to say. But the question is, how do we do that? That's easy. So we are still going to say the same thing. We write it officially. We go to the first triangle first. We say, if we take those ones and we add them up, the answer is 180. Of course, you'll finish the reason. Sum of interior angles of a triangle. But we know something. What is that? We know that angle D is equal to angle E1. I'm not sure why did I say E2. Should have been E1. Sorry about that. Yes, we know that angle D is equal to angle E1. Well, that's because they are angles opposite equal sides. So isosceles triangle, because the two tangents are equal to each other, they are tangents drawn from the same point. So what? Well, if you like here, you can choose to say, well, since I know that these two are equal to each other, okay, no. I wasn't making a mistake. It should have been E2. It really should. It should have been E2. Wait, E2, no, E1. Hey, C plus D plus E1, okay? Yes, but we know that D is equal to E1, okay? So let's say maybe you want to express angle D in terms of this angle C. So then what are you going to say? I want you to watch this closely. If you go to these two, we know they are equal to each other, right? So you can decide to say twice as much angle D. Yeah, D plus E1 is the same as twice as much angle D. You could have decided to say twice as much angle E1 if you so prefer. But twice as much angle D is equal to 180 degrees minus angle C. That's what I'm saying. And of course, if you like, you can divide throughout by 2. But we wouldn't want to get fractions, would we? Even though this one would give you a straight or rather a clean 90 degrees, but this one will give you C over 2. So we don't want fractions. Let's just keep it as twice as much angle D. Okay. Then we can move on to the other triangle. But in the other triangle, I believe it's still necessary for us to convince them that those two sides are equal to each other. So let's do that. So we say EK is indeed equal to EH because they are radii of your circle. So what? So this means angle K1 must be equal to angle H. Well, I began in the wrong order here. I should have begun by saying adding those up, we get 180 degrees, né? And I should have said that. Wait. Now it's revealing things that shouldn't be revealed. It's showing the full circle now instead of a semicircle. But that's fine. Anyway, I still want to do it in the right order. Now, the logic is key. So I'll just change and write in blue to show that I'm now in a new triangle. How's that? Fine. I'm saying if we go to the smaller one, we take angle K1, we add it to angle H, we add it to angle E2, we get 180 degrees. For the same reason as the other one, the sum of interior angles of a triangle. Before we say those two angles are equal to each other, I believe it's necessary for us to convince them. Remember, we are in court and we want to prove beyond reasonable doubt. That's what the magistrate will tell a lawyer. So let's go. We say, okay, fine. We know that EK, yeah, we can actually say a but here. It fits. But EK is equal to EH because they are that, which means that angle K1 is actually equal to angle H. All right? And since those are equal to each other, why are they equal? Well, angles opposite equal sides. So this means I can choose to express either K1 or I can choose to express, oh, I said EH. Thank you, sir. I should have said EK. Right. Yes. What am I saying next? Oh, I say I can now express this either K1 or H in terms of E2, right? But I know that E2 is equal to C. Well, that's fine. So let's say I go to K1. So I say twice as much angle K1 is now going to be 180 degrees minus E2. That's what I'm going to say. Okay. But of course, I know that E2 is equal to angle C. So this means twice as much angle K1 will be 180 degrees minus angle C. What did I do here? I have now shown that 180 degrees minus C is equal to 180 degrees minus C. So the conclusion I can now draw is this means twice as much angle D is twice as much angle K1, which would further mean that angle D is equal to angle K1. Do you see that? Okay, now I have made two connections. This is the first connection, and this is the second connection. Then what's the third connection? Well, it now stands to reason that E1 is equal to angle H due to the sum of interior angles of a triangle. Then what's the conclusion? Well, now we can nicely conclude and say triangle DCE must be similar to triangle HEK. It's 6 marks anyway, so it's worth waiting for it. The point I'm trying to achieve here is just because these are angles opposite equal sides, and these ones are angles opposite equal sides, please don't assume that they're equal to each other. Show us, convince us, and we can gladly give you all the marks. You deserve them. So before I can erase anything here, I just need to mark the angles that are equal to each other. So we know that C is equal to E2 and D is equal to K1, right? Then it stands to reason that this one is equal to that. Awesome. So now we are going to go through life understanding that the two triangles are similar to each other. Ish. Hey, I don't know how can I do this. Does it mean I'll have to go back for everyone? Yeah, that's what it means. I'll just so we said this angle here, E2, is equal to angle D. No, I'm lying. It's equal to angle C. K1 is the one that's equal to D. Right. And of course, angle H will be equal to that one. So we don't need to show that. So what does the next question say? It's a really short question if you ask me, but it says, please prove to us that DG is equal to GE. How many marks is it? 3 marks. In other words, we need to prove that DG is equal to GE. Well, that's fine. The easiest way for us to prove this is by showing that, yes, this is the center of the circle. Yes, this tangent is actually a line from the center of this circle. Now, if we can show that this line is perpendicular to the chord DE, then definitely it bisects the chord. All right? So that's what we need to do here. But the question is, how can we prove that this angle is 90 degrees? Well, easy. This is a tangent, of course, and this is a radius of a circle. And we know that the tangent is perpendicular to the radius. So that's what we are going to say here. We say angle FGE. Well, I've always struggled with writing a G, but nonetheless, angle FGE is 90 degrees. Reason, we just said it. The tangent is perpendicular to the radius. Okay, fine. So now we know this is 90 degrees. If we know this, then we can safely conclude and say, this means that DG must be equal to GE. And what's the reason for that? Well, it's the converse of is it really the converse? It's not the converse, it's the theorem itself. Yes, it's a theorem. The line from the center perpendicular to the chord. That line bisects the chord. Yes, this is the easiest way to really show that, yeah, that is that. So yes. Is there another way in which you could have done it? Well, I can't think of another way. Anyway. Well, this is the next question, which is the last one for the day. It's a 3-mark question. What does it say? Well, in this case, they are asking us deep down from the bottom of their hearts to please prove that twice as much the square of HA will be DC times HK. Well, that's what they say. So if we look at HA, we see that it is in this triangle, DC, in that triangle, HK, in this triangle. So they're in the triangles that contain, no, the ones that we have proven to be similar to each other. So then let's go ahead and state our corresponding sides, knowing that the triangles are similar. So how does it work? Well, easy. So we need to find the corresponding sides. We just go to the angles that are opposite each other. So we know that angle E2 is equal to angle C. This means if you take KH in the smaller triangle and you divide it by DE in the bigger triangle, you must get exactly the same as when you take HE or EH in the smaller triangle divided by CE in the bigger triangle, yes? Which in turn must be the same as when you take KE or EK in the smaller triangle and you divide this by CD in the bigger triangle. And you'll state that this is because our triangles are similar to each other. But of course, you're not going to write all three of them. I'm just writing all three of them so that I can see which one must fall away. We have DC here, which is CD. We have KH there, which is HK. We don't have CE. We don't have HA. So it stands to reason that this one we are not going to show the examiner. We only take those two other ones. So, yeah. No, we don't take that one. So you only equate these two in your workings, all right? Then if you now go here and you can cross multiply, and you'll find that KH, which they prefer to say it is HK, times CD, which they will prefer to say it is DC, will be equal to what? To KE times DE. That's what you get when you cross multiply. All right? Well, now you can observe something. What is that? You see that this side is actually happy because it's exactly the same as that. Now it's time for us to deal with this side here. So how do we deal with KE and DE? Okay, no, seems like I lied to you a bit here. Okay, I did. But did I lie? Yes, I did. Because HE is here. Yes, HE is here. And okay, seems like this one of KE and DE is the one that I shouldn't have taken, right? Okay, no, that's that. So let's fix it. It means the other one is supposed to be the one that falls away. Sorry about that. But I'm glad you now understand that old men make mistakes. Right. So that when we now cross multiply, what are we going to get when we cross multiply those two? Well, it won't be happy anymore. No, it won't. So maybe it's much more complicated than how I looked at it. But let's see. Let's see. Okay, so if I cancel that one out, then it means, yeah, I see that. If I do cancel those ones out, then it's really going to be a mess. Okay, I see. This is one way in which we could have stated our proportionality, or rather our corresponding sides. But I actually want you to realize that you could have done it differently. Differently how? Instead of saying K1 equals D, you could have decided to say K1 is equal to, I'll just use green and override them. You could have decided to say K1 is equal to E1. And also, you could have said angle H is equal to this one. Okay, it won't make sense if I do that. Let's say this one and that one. So if you had said it like that, then what would the corresponding sides be? I want you to see. Well, HE is now going to correspond with CD. And KE is now going to correspond with CE. And what is the remaining one? KH is simply going to correspond with DE. This is another way in which you could have written it. Remember, at the end of the day, we've shown that these angles are equal to each other, and this one is equal to that one. So you can write your proportionality in two ways for the similarity of those angles, because those angles are actually equal to each other, just that we chose to show that D is equal to K1, but D is also equal to H. Why? Because K1 is equal to H. So that's that. Okay, fine. Supposing we wrote it this way, then can it help us? Let's see. Well, let's look at what we are hoping to achieve and make a conclusion from there. So according to this, let's see, can we get CDHK? Of course we can if we cross multiply those. And then we can get an HE now. Okay. I think that this way that we used now is much better in terms of achieving this. So let's forget about this one. Yeah, let's do. So that when we cross multiply here, we are just going to get HE times DE, which is equal to KH times CD. So this one is happy once again. Now we just need to deal with DE. Yes. How can we deal with DE? To be more precise, we need to express DE in terms of HE. That's all we need to do, and then we should be fine. And as a matter of fact, we can do that. Why? Well, that's because we know that DE is actually twice as much, or maybe I should have begun it here. Where should I have begun it? I want you to realize that DE is the diameter. Diameter how? It's not the diameter, it's just the sum of DG and GE, which means that it is just twice as much GE. But then we want to express it in terms of HE. So we know that GE is equal to that one because they are red eye. Yeah, no, that's what I'm saying. I'm sorry I'm now struggling to put it into words, but let's show it in writing. We know that GE is equal to EH or HE because they are radii. And we also know that DG, not really DG, but the whole of DE is twice as much GE. Well, this one was proven. When we proved that DG is equal to GE, we were also proving that DE is twice as much GE. It stands to reason. So then this means our DE is twice as much HE. That's the connection we needed. Then we can now come and say, okay, fine, where to from this point? We now go back to this ratio and we expand on it. Then we say we have HE, but when we see DE, we now see twice as much HE. And this is equal to, of course, KH times DC as they preferred. Then it's now easy. We have twice as much HE, which is squared. And this is equal to KH times DC. So yes, the most important thing was here. Please note that there were two ways in which you could have stated your corresponding sides. Yes, because those base angles, all four of them, they are each equal to each other. So please note that. If it fails the first way, then remember that, man, these things are actually equal to each other. So I can state it the second way. And then once you have achieved the one that you want, then we now had to express DE in terms of HE, and we successfully did that. So yes, that's where your 3 marks will actually come from, and you are happy. Over and out.